Hi, this is Ruby Rubin, and I'm here to talk all about reactions. So, the first step in understanding reactions is to know the 6 types. So, the first type would be synthesis, and it's a compound created from parts. So, here I have A plus B equals AB, so they're being combined. The second type is decomposition. So, this is a compound that breaks into 2 parts. So we start with AB together, and it ends up being A plus B. The third is single replacement. This is when a lone element is substituted into a compound. So here we have A plus BC equals AC plus B. So what happens here is A is replacing B. So now it becomes A and C plus B because A is replacing B. A continuation. So the fourth type would be double replacement, which is when 2 ions in a compound switch roles. So we have AB plus CD equals AD plus CB. So what happened here is A and C switch roles. So then it becomes AD plus CB. The fifth type would be acid-base. So this is when a double replacement occurs with 1 ion being an H. So here we have HA plus BC equals HC plus BA. So what happens here is H and B switch roles. So it's a double replacement with an H. So H now is with C and B is now with A. The sixth and final type would be combustion. So this is when a fuel burns an oxygen to create CO2 plus H2O. So it's always going to create CO2 plus H2O. So here O2 is creating CO2 plus H2O. Examples using elements would be down here the 6. So synthesis, an example using elements would be Na plus Cl ends up creating NaCl, so they're combining. Decomposition would be KCl, ends up being K plus Cl, so it starts combined and then it breaks down into K and Cl. Single replacement would be Li plus NaCl, end up creating LiCl plus Na, so Li is replacing Na to be with Cl, and Na ends up being on its own. Double replacement, we have AgNO3 plus NaCl creating NaNO3 AgCl. So Ag and Na are switching roles, so now the Na is with the NO3 and Ag is with Cl. Acid base would be HCl plus NaOH creating NaCl plus H2O. So the H and Na are switching. So now the Na is with Cl and H is with OH, which is H2O. Combustion, we have CH4 plus O2 creating CO2 plus H2O. So CO2 plus H2O is always created in combustion. Okay, balancing is another very important aspect of reactions. So the number of each element must be equal on both sides of the reaction. So you have to have an equal amount on both sides of each element, yeah. Okay, so an example here that's wrong would be Na plus Cl2 equals NaCl. So the reason why this is wrong is because Cl is a diatomic, so there's 2 of them on the left side, and on the right side there's only 1. So that's not equal. So the right way would be 2Na plus Cl2 equals 2NaCl. So on the left side, we have 2Na and 2Cl, and on the right side, we have 2Na, 2Cl. So the number is equal. A second example would be Na2 plus H2 equals NH3. So this is wrong because there's 2 Nas and 2 H on the left and only 1 N and 3 H's on the right. So that's definitely wrong. And so the right way to do this would be to have 2 Nas on the left and 3 H2s. So those multiply to equal 6. So on the left you have 2 Nas and 6 H's, and on the right you put a 2 in front of the NH3 to have 2 N's and 6 H's, because those again multiply to equal 6. So now you have an equal number on both sides. Single replacement rules. Okay, so for a single replacement reaction to work, the metal replacing the other metal must be higher on the activity series. So on the right, it's kind of small, but you can see the activity series. So at the top, going down, it decreases. Okay, so this also applies to nonmetals, but I used metals as an example here. So K plus CaCl2 equals KCl plus Ca. So this is a single replacement, and it works because K is potassium and it is above calcium. So K is replacing Ca to be with Cl, and then Ca is on the end. So the reason why this works is because, again, potassium is above calcium on the activity series. Therefore, it can replace Ca. Double replacement rules. So for a double replacement reaction to work, at least one of the elements on the product side must be a solid, which means it isn't soluble. So that is applying to the picture here. If it says it's soluble, it means it's aqueous, and if it's not soluble, it means it's solid. Okay, so we have AgNO3 plus NaCl equals AgCl plus NaNO3. So this is a double replacement, and Ag and Na are switching. So Ag is now with Cl, and Na is now with NO3. So the reason why this works is because on the right side, you use the solubility chart to look at, you find Cl, and you look plus at the plus sign, and here we see Cl plus Ag is not soluble, which means it's a solid. And then NaNO3, you take NO3 and you look on the chart and you see that NO3 plus any positive ion is soluble. So Na is a positive ion, therefore it's aqueous. So because we have AgCl on the right side being a solid, it ends up being a working reaction. So finishing a reaction. So the steps to finishing a reaction go like this. Number 1, you have to identify the type of reaction. Number 2, you execute. So you switch if it's a double replacement. If it's a single, you replace, and combustion, CO2 plus H2O. Third step is to balance, and fourth is to check. So here's an example. So if we were given the reaction Na2S plus HCl, we have to do the steps. So number 1, I realize it's a double replacement, which means Na and H will be switching places. So number 2 is executing. So we have Na2S plus HCl equals NaCl plus H2S. So again, H and Na switch to have Na now be with Cl and H be with S. So the third step is to realize that there are 2 N's on the left and 1 N on the right. And in addition to this, there are 2 H's on the right and 1 on the left. So we need to fix this problem by balancing. So there's 2 NA's on the left, which means we have to have 2 on the right. So if you put a 2 in front of NaCl on the right, NA's are now balanced. But now Cl also has 2. So because you have 2 on the right, you need 2 on the left. So now you have to put a 2 on the left in front of HCl. And then you have to check. So on the left we have 2 NA's, on the right we have 2 NA's. On the left we have 1 S, on the right we have 1 S. On the left we have 2 H's, on the right we have 2 H's. And on the left we have 2 Cl's, and on the right we have 2 Cl's. So now we realize that they are all balanced, which means we're good to go. Thank you for watching, and I hope you learned a lot from this video, and yeah, have fun doing reactions.